Hello everyone. Today, let's learn together why it is necessary to control the frequency and active power of the power system. I am the main teacher Liu Qingping. As we can see from the guidelines of the security automatic equipment, there are several basic requirements for security automatic equipment. The first requirement is that when a single fault occurs in the power system, for example, only a single phase rounding occurs, it should maintain stable operation of the system. The second requirement is that when multiple faults occur in the system, or the system cannot keep stable operation. For other reasons, when the system is operating normally, the accident scope should be minimized, the accident duration, and large-scale power outage or system collapse should be avoided. The third requirement is that after an accident occurs, it should recover the normal power supply to users as soon as possible, so as not to cause a long power outage. When a system accident occurs, if it damages the stability of the power system, then control measures should be taken accordingly. For different control objects to take different measures. For example, for the sending end, if the control object is the power supply, should adopt cut machine, electrical brake, and other automatic control operations. For the receiving end, if the control object is a load, you need to use automatic low-frequency load shedding or low-voltage load shedding for control. If the control object is the power supply, you need to use low-frequency auto startup unit for control. If the system after some accidents, these accidents may cause large-scale power outages. This time, it is necessary to use automatic splitting devices. So, in this program, we focus on learning about automatic load shedding device by frequency. So, what is an automatic load shedding device by frequency? That is to say, when there is active power shortage in the power system and causes the system frequency to fall according to the frequency magnitude, automatically removing a portion of the unimportant loads in turn to prevent the frequency from falling, making the frequency to return to the normal operating value as soon as possible. This device is called automatic load shedding device by frequency. It is an important device to ensure the power supply of important users and to avoid the accidents caused by frequency drop, such as frequency collapse and system disintegration. So, what are the hazards of low-frequency operation to the power system? We know that electrical energy has two main quality indicators, which we all know as voltage U and frequency F. When the power system operates normally, the voltage and frequency are operating near their rated values. If the frequency deviation from the rated value of 50 Hz is relatively large, then it may damage the power equipment, reduce productivity, affect product quality, and a series of hazards. It also poses a significant threat to power plants and power systems. Then, we analyze the hazards of low-frequency operation from two aspects, the user and the power system. The first is the impact on users. The first is that changes in the frequency of the power system will cause changes in the rotational speed of the asynchronous motor, which will cause changes in the rotational speed of the machinery driven by the motor to process industrial products, seriously affecting the quality of the produced products. The second is that power system frequency fluctuations can affect the accuracy and performance of certain measurements and control electronics. Some equipment may not even work if the frequency is too low. This is absolutely unacceptable for critical industrial and defense applications. The third is that the frequency reduction will make the motor rotational speed and output power reduced, which will lead to the reduction of the rotational speed and output of the machinery driven by it, affecting the normal operation of the equipment of the power users. These are the impacts on users. Next, we analyze what the impacts will be on the power system. The first is the effect on the turbine blades. If the frequency decreases, the vibration of the turbine blade will become stronger. If it is not serious, it will only affect the turbine's service life. But if it is serious, the turbine blade may appear cracks. Generally speaking, if the frequency is as low as 45 Hz, some turbine blades may break due to resonance, causing serious accidents. The second is that it may cause the system frequency collapse. If the frequency drops to 47 to 48 Hz, the output of the thermal power plant machinery, such as blowers, suction fans, feed pumps, circulating water pumps, and coal mills, etc., driven by asynchronous motors, will drop so that the output of the thermal power plant, boilers, and turbines will also drop so that the active power generated by the generator of the thermal power plant also dropped. If this tendency is not stopped in time, may cause the frequency of the power system to drop to an impermissible level in a short period and lead to a frequency collapse. If a frequency collapse occurs, it can cause widespread power outages and even collapse and disintegrate the entire power system. The third is that it may cause the reactors in a nuclear power plant to stop operating. This is because the reactor's cooling pumps have very strict requirements on the power supply frequency. When the frequency drops to a certain value, the cooling medium pumps will automatically drip off, and the reactor will stop operating. The fourth is that it may cause the system voltage to collapse. When the frequency drops, the excitation current and reactive power assumption of the asynchronous motor and transformer increase, causing a voltage drop in the whole system. The frequency drop also causes the exciter output to drop and causes the generator electromotive force to drop, which leads to a decrease in the voltage generated by the generator. If the original voltage level of the power system was relatively low, then when the frequency drops to a certain value, there may be a rapid and continuous drop in voltage, a voltage collapse phenomenon causing large-scale outages or even disintegration of the system. Just now, we analyzed why we need to control the frequency. Here, we will analyze why it is necessary to control the active power of the power system, mainly including the following reasons. The first aspect of this is that active power control can keep the system frequency within the permissible limits. This is because the frequency is maintained in balance by the sum of the active power produced by all the generating units operating in parallel within the power system and the active power consumed by all the loads in the system. The second aspect is that active power control can improve the economy of power system operation. There are two main aspects. The first aspect is that under a certain load, it is necessary to determine which units are to be put into operation in the power system, and which requires consideration of the efficiency of the generating units. the coordination between various generating units such as hydropower, thermal power, and nuclear power, and the great loss of the power system. The purpose of coordination is primarily to improve the economy of power system operation and reduce costs. The second aspect is to ascertain the active output of the units, operating in parallel for that low case. The first aspect is the problem of economic dispatch of generating units. The second aspect is the problem of economic distribution of active loads. The third aspect is that active power control can ensure the coordinated operation of the combined power system. Because of the expanding scale of the current power system, it is required that several regional power systems be linked together to form a combined power system. These combined power systems require zone control, which means that the electric power and electricity exchange between the systems in different regions are carried out according to the previously agreed agreement. This time, the active power control of the power system should be implemented to control the power and electricity passing through the contact line between different regional systems. So, the frequency and active power control of the power system are closely related and inseparable, and should be considered in a unified and coordinated control. This is the reason why we need to control voltage and frequency. Today, we have mainly studied the basic requirements of security automatic devices, the definition of low-frequency load-shedding devices, the hazards of low-frequency operation, and the reasons why we need to control frequency and voltage, these aspects. So, that's all for today. Thank you.